Fantastic. Okay. So welcome everybody to this afternoon session, which focuses a little bit on the transformational impacts that research infrastructures can have. My name is Johannes Gutleber. I come from CERN, the European Organization for Nuclear Research, straddles the border of between Geneva and Switzerland. We will have 5 speakers this afternoon in this session. I'm the first one, and then I have the pleasure to moderate a discussion session also with my 4 other colleagues who are all distinguished scientists and can tell also about all their local and regional transformational impacts of their research infrastructures. So, to start with, we talk about the future, and I brought you a piece of the future here. It's very small, can't see it very well, so that's why I put it here also on the slide. If you want to know what that is, feel free afterwards, come and touch it. I will not give it to you, it's my little treasure. Let me start a little bit on the topics. So where do we stay with particle and high energy physics? The Large Hadron Collider is a marvelous piece of a scientific product. It has brought together a whole community of the world to complete the standard model of particle physics. That's the state, but that's not the end. With the discovery of the Higgs boson, it's not a story that has been closed. It's a whole book of science that actually has been opened. And scientists are eager already now, although the LHC program is still ongoing and will be ongoing for still many years to come, scientists are eager to prepare already the future afterwards, because as the LHC, the Large Hadron Collider research program is ongoing, scientists see more and more inconsistencies between the observations that they make with this particle collider and with that famous standard model of particle physics. So open questions are still, what is all the universe really made of? Where is all the mass that is today unknown? Is the universe only composed of matter? Or where has all the antimatter gone? What is the true nature of the Higgs boson, which has been experimentally confirmed at the Large Hadron Collider? Is there only a single type? Why do neutrinos have mass? Something that the standard model of particle physics does not predict. And how do they get it? So you see there is numerous open questions still that request research infrastructures, particle colliders, which are of kind of a different type, questions that cannot be answered or not satisfactorily be answered with the Large Hadron Collider and its upgrade. So this is where scientists came together and discussed about options for future particle colliders. And one of these options is what we call Future Circular Collider, a science mission that is conceived from the bottom up by global collaboration that came together with a research program that can last until the end of the 21st century. And it consists of 2 particle colliders. Actually, first an electron-positron collider built in the new underground infrastructure, and then a hadron collider to come after it. What you see here in the image, the blue thing is the Large Hadron Collider, and the red thing, that would then be the Future Circular Collider, which would have a circumference larger than 90 kilometers. So I wanted to talk a little bit about the socio-economic impacts that we have studied so far today, about the many scientists over the years that such a research infrastructure could host, tens of thousands. Then I thought I could also talk a little bit about the industrial spillovers, the multiplication factors, 1, 2, or 3 that we could achieve by conceiving such a research infrastructure. I thought I could also talk about the generation of jobs, which we have found out is in the order of 200,000 or more. I thought I could maybe talk about the tourists that are coming to see CERN and its scientists, more than 250,000, probably 300,000 in the end per year. Contributing significantly to the local economy. I thought I could also talk maybe about the energy, the renewable energy concept that we are developing to power such a world-class instrument, and how actually not only we can consume energy, but how actually a machine like the FCC can even contribute to the energy transition in Europe. Or I thought I could talk a little bit about how we recover the waste heat and how we contribute locally in our area already today with the Large Hadron Collider, and even more in the future with the operation of our infrastructure to the local cooling and heating needs. But then I thought, well, this is all things that probably you have heard about it, and you have experts in socio-economic and cost-benefit analysis who can tell you about it. My teacher was here, Massimo Florio and Silvia Vignetti, and they know all much better these kind of things because really they're doing this every day. So I thought what I'm going to talk about is what you really need, apart from the other things, and that's knowledge. But hang on, the future circular collider is not there yet, so I can't really talk about the generation of knowledge. And as we have heard it also, I can also not give you a guarantee what kind of knowledge humankind is going to obtain from a research program that will last until the end of the 21st century. But I believe that the research infrastructure of such a scale can really be a platform, a global platform for generating knowledge and transforming by this generation of knowledge already during the phase of the design and the construction, how it can transform different regions in the global project, and how also within the region, locally, it can contribute transformationally to the society. So this is where then this thing will afterwards come in the game. What we're trying to do with the FCC today is showing project feasibility through the concept of open innovation. Open innovation is not something new, but I didn't see it really very well implemented in a lot of places so far. So I thought for us this could be something, if we build it in from the beginning onwards, it's a kind of a guarantee actually for socio-economic impact generation and transformational things. So let's build this platform and open innovation, and people come together that through a new vision generate impact. Let's try to put that in place. Let's put the concept up there, and this should be the vehicle that drives FCC forward, because it leads to a brain gain rather than a brain drain. So what you see here in this picture is this concept of open innovation, where we have a core process. The core process is the scientific mission. We heard it also in the talks beforehand. We do not put that into question. The scientific excellence has to be there from the beginning onwards. It's binary. If it's not one, we shouldn't even continue with thinking about how we can generate regional impacts or local impacts. But we, the scientists, the particle physicists, the high energy physicists, the particle accelerator experts, our competence is in this core mission. It is not in the mission about the material science for the new superconducting magnets. It's not in the electronics that we need for the detectors. It's not in the even socio-economic impact generation and analysis part. So we can get in people from the outside because we have a vision, and we would like to have this vision happening. We would like to implement that vision, and to have it implementing, we need the knowledge from the outside. And turns out that people like it. They find that actually very intriguing, very stimulating. They have an enthusiasm. They find the meaning of life in contributing to an FCC idea, maybe not even knowing if FCC will ever happen, but already contributing to it today and generating impact. And what is nice also is that when we get these people with their knowledge in, the companies and these other research infrastructures and research centers, they produce actually new knowledge that turns out to have a very tangible economic value and societal transformational capacity. So for the FCC, we put in place an open network environment platform, FCC1, that really creates this network of different stakeholders around Future Circular Collider vision building, companies, research organizations, universities, schools, citizens, funding agencies, and we create a possibility for them to join, to interact, but also to transact. Transact not only with their minds, but also transact in terms of tangible items and financial transactions. A specific example on that is the excavated materials that occur if you want to dig such a tunnel of 90 kilometers of length. Several millions of cubic meters would be created during the construction years, and we have to do something about it. Unfortunately, 95% of this material is what we call heterogeneous sedimentary molasse material, and this is something where today no industrial reuse of this material exists. So we thought, we would like to build this accelerator. We don't know what to do with all these materials. So we have to think about something, but we are not the experts in that game. So open innovation. Let's get in a community, and we built around a worldwide competition where we invited consortia from industry and academia to work with us together to find ways to make this happen, because it can't be that this material cannot be reused. So in the end, then, the plan should go in a credible strategy for the management of the excavated materials, which is a feasibility criteria. So this competition is called Mining the Future. It came to an end just last month, and it is just one activity in this one platform, where the goal was here to identify the credible concepts for the reutilization of the molasses. This was actually the winning solution. It's a plant that can be built directly on the construction site. From the raw materials, you'll have an online, near real-time separation of the materials, pre-treatment of the materials, and you can use that then with a new novel binder that is actually low carbon to have a kind of a concrete that is sprayed with robots to build foundations and some buildings of the surface sites. And also the material can be used to produce earth bricks. So this is the solution of the riddle. This is the first earth brick from molasse that was part of our winning competition. And it's quite solid. Testing is still underway, of course, but this is the kind of things that we can do with it. And it will not only have impact on our surface sites, but we can also promote it in the region to have building materials where we have our excavation sites. Again, reducing carbon footprint, reducing resources, and stimulating local economy. Another possibility that has been found out is that this material, if it is enriched with some type of mushrooms, so I'm not the expert here, actually is quite fertile, and you can use it to improve the quality of agricultural land around. Now, it turns out that in the region where we want to build this particle accelerator, the land is not flat. So you have quite some mountains there, you have a lake there, but in between there are slopes and depressions. And talking actually with the local government, turns out that the local government would like that we contribute to improve the situation of the agricultural land, make it more flat, be able to access it with machinery easier. So again, we have a local reuse here. The idea is to avoid massive transportation of the excavated materials with trucks and even with train, but to reuse the maximum on the adjacent slopes that are around the surface sites, the access sites of such a subsurface particle accelerator. So this leads to a locally innovative approach to use the treated materials to levelize the neighboring agricultural fields and forests, improve the agricultural spaces, make the forests fit for the climate change and easier to access for the wildfires. We know already the projection on, unfortunately, on how the situation will evolve in the region, and to produce locally low carbon concrete or earth bricks to build the surface sites. So these are then the benefits compared to a traditional construction, so quite a convincing case. And there is even more added value to the society in that, because currently excavated materials in Europe are considered waste. And waste, you cannot reuse it in another project. So, fortunately in Switzerland and in France, there exist national guidelines. And if we can have a pilot or a demo project showing that this thing actually works, and we work with the local governments together, the notified bodies would include such pathways or scenarios in their national guidelines. And if that really happens, also other projects could profit from this, because we have shown that it works, it can be picked up, and that is sufficient for France and for Switzerland to let this scenario happen also as a legal or regulatory permissible case for other construction projects with similar requirements. So to come to an end of that presentation, what I would like to maybe as a message to give on the way is that when I'm talking about a vision for a future research infrastructure, not knowing actually if this future research infrastructure will happen in my lifetime or will ever happen, I believe there is an enormous potential in there if we propose something that is really bold and out of the normal in the positive sense, that can really contribute in many different ways, in even unthinkable ways, to transitions in the society and in the economy. And even if you look at these United Nations Sustainable Development Goals and you wonder yourself, but how would have high energy physics or particle accelerator ever anything to do with such kind of goals? You just need to dig a little bit and think a little bit, and actually it can have a lot to do with it, and it can really make a big impact. Thank you so much for this one, and I propose we have our next speaker with us, and that's Adrian Tiplady. I'm not sure if I pronounced that correctly, Tiplady, from South Africa. He is remote with us, and he will talk a little bit about the South African efforts on radio astronomy installations. And again, I think a research infrastructure in an area that is quite deserted, but probably he is going to tell us a little bit on how even this concept of this infrastructure has some transformative effects on the region. Adrian, your turn.
Great. Thanks very much, and thanks very much for having me. And you absolutely pronounced it correctly, Adrian Tiplady. And I think the theme that I'm going to be speaking about really is about the concept of advancing a social license to operate for sustainable research infrastructures going forward. I'm from the South African Radio Astronomy Observatory in South Africa, and it's been responsible for implementing South Africa's strategic investments in radio astronomy. And historically, that was operation of the Hartbeespoort Radio Astronomy Observatory just outside of Johannesburg. But over the last 2 decades, there's been an exponential increase in investment in radio astronomy, and that's given rise to the design and development of the Meerkat radio telescope, which is in fact a precursor to the International Square Kilometre Array radio telescope, to be located both in the Northern Cape province of South Africa and in Western Australia. And really our vision is to undertake multidisciplinary technology and scientific research and delivering science and technical solutions to the astronomy community. But I think it's important to recognize that the investment in in research on infrastructure has perhaps changed over the last number of years. And certainly at the time of investment and development of the Meerkat radio telescope and currently the SKA, the global context has changed. And I think the greater need for demonstrable societal impact is born from increased global connectedness. The quick and easy and efficient sharing of information has created a more knowledgeable and empowered society that is demanding more socially and ethically responsible behavior from investments. And I'd like to draw an analogy with the corporate sector. Historically, the corporate sector's mandate was, in most parts, to deliver profit to its shareholders. And that has moved, and that has changed. And what we've moved to is from a shareholder model to a stakeholder model, where one of the primary mandates is to deliver value to its stakeholders. And I think that translates very well with the broader public investments in research infrastructures, where we have adopted a stakeholder model. And the way we internalize this within Soraya is we've embedded principles to ensure long-term sustainable acquisition and operation of Meerkat. And what this does is it creates a segmented approach in identifying our stakeholders, to deliver value to our stakeholders, but also deliver local value to local stakeholders. And that's really conceptualized in this idea of owning a social license to operate. Are we ultimately delivering value to local communities? And just to give you context of what that local community looks like in the case of Meerkat and the future SKA telescope. Meerkat is located in a very semi-arid region in South Africa known as the Karoo. And we established a greenfield site. We only really started establishing it in sort of late 2007 or so quite recently. It's very sparsely populated. It has primarily an agricultural economy, mostly sheep farming, but just to give you a sense, the carrying capacity of the land is of the order of 1 sheep every 7 to 8 hectares. So the land tracts are extremely large, at least 10 to 15,000 hectares in size per farm. It's very economically depressed. So there are 4 towns in the vicinity of the Meerkat site, approximately 80 kilometers apart. And there's a large reliance on social security. So on the doorsteps of Carnarvon, we are building and have built the Meerkat radio telescope, 64 13.5 meter dishes. It's currently being extended to approximately 80 dishes. It was commissioned in 2018 and has really been doing some outstanding science. And in fact, many groundbreaking scientific outputs have established Meerkat as really a global facility. As I mentioned, it is a precursor to and will be integrated with the SKA project, which is just commencing construction. And so what we've done is we've really embedded this idea of establishing a social license to operate in what we do, because it's not separate to the delivery of a research infrastructure. It is absolutely vital to ensure the future sustainability and operations of Meerkat and the SKA. It's important to ensure that we realize value for local communities. And the way we've done this is through a number of strategic thrusts. And this falls within a broader benefit framework of the contributions of research infrastructure in terms of the public good and research enterprise and scientific endeavors. But really these 3 areas that I've identified here, education and skills development, community investments, and business and enterprise development, so really are the strategic thrust through which we've had directed interventions to ensure that we are investing in all of these 3 areas. So in the area of education and skills development, of course, Soraya does have quite an extensive bursary program, but really that bursary program and the approach we've taken is a pipelined approach. And the pipeline approach starts in the communities at the schooling level, recognizing that the community and certainly the schools have learners that are not able to take STEM subjects through to the end of their schooling career simply because of the lack of qualified maths and science teachers. And so we've had to employ at least 3 STEM educators at the local high school, Carnarvon High School. We deploy reading programs, robotic programs, and various other education programs in the 9 schools in the area, with a view that we will be able to support these learners into further education, training as artisans or technicians, such that there's community involvement in the construction as well as the operations of the research infrastructures in the local vicinity. We have a bursary program where we support a wide range of individuals, but specifically we're supporting learners from the local towns to attend the Carnarvon High School to be able to study STEM subjects to grade 12, as well as ongoing support within the universities and universities of technology. We have artisan training, and we've established an artisan training facility in the area to ensure that we're able to effectively grow our own crops and ensure that local community is participating again in the maintenance and operations of the research. Then we talk about business enterprise development, and I think what is important here is what the ultimate outcome is. We're trying to lower the barriers to economic opportunity. And we do this through 2 ways. Well, firstly, ensuring that there are opportunities made available through our own procurement practices and procurement policies, but also around developing the local business skills to promote downstream economic employment and economic development. So we run what is called a Karoo Enterprise Development Program, which has been extremely successful in developing local businesses to be able to successfully subcontract for Meerkat, participate in the operations, and in the long term, positioning themselves so that they can take opportunities from SKA-related construction and operation activities. We have a Meerkat Creative Community Initiative, and this is really not just about supporting potential local businesses and local economic activities and supporting actors within the local economy, but also investing within the community and within local culture. We have ICT support programs, online learning, educational programs, etc., and it's been particularly a successful program. The third strategic thrusts relate to community investments. And I think here, this is extremely important to ensure that Soraya is seen as a responsible and participatory citizen. Because I say this tongue-in-cheek, we could have built a soccer stadium next to the town. And at the time, it may have been seen as more value add to the local community. Right? And so you need to be able to make the research infrastructures accessible. And you also need to be seen to be part of the community. And I think this is extremely important. And so we provide things such as annual development grants, and so investing into the local infrastructure, local social development programs. Of course, there's ongoing science engagement and engaged research in the communities. Participation in cultural and sporting events, and also promotion of indigenous cultures. Particularly within the area of the Meerkat, we have what is called the Reel dance, which is extremely one of the oldest forms and traditions of dance within the local indigenous people. I mentioned the Meerkat Creative Community Initiatives. We have medicinal plant studies to try to broaden the scope of research and understanding and broaden that knowledge base that exists and try to extract new information from the indigenous knowledge systems that do exist within the communities. And of course, promotion of sustainable development goals in every aspect, in everything that we do. We have for example, a local value policy that directs program managers and project managers that are deploying projects within the area to try to identify and maximize opportunities for the development of local value without introducing any kind of technical, financial, or programmatic risk to the actual project. So one of the things, and one of the pictures I've got there, for example, is an impact study, and I think this is really important to note, is that monitoring and evaluation of your activity is extremely important in respect to monitoring of impact. So two of the impact reports there, we've got one related to our hosting of the Hydrogen Epoch of Reionization Array. It's another radio telescope that was attracted to the site because of the scientific quality of the site. And what is really interesting about that project is that apart from the receivers that were deployed and specially designed, the actual antenna structures were all built and deployed by local artisans, local technicians, and the materials provided by local suppliers. As a result of many of the efforts that we've undertaken to build up the business enterprise within the local communities. The other area in which we invest, of course, is in data science and many data science activities, and we've got a very high proportion and participation of women in data science and really addressing gender equality and gender diversity within the scientific and STEM programs. So just a couple of closing remarks. I think research infrastructures now, and specifically new research infrastructures, play a very key and visible role, and should play a very key and visible role in supporting socio-economic development to ensure their own long-term sustainability. But in order to ensure this, I think there needs to be a recognition of a diversified value proposition, where one considers not only a local, but a global, but also a local value proposition in what we do. And for us, we conceptualize particularly delivery of a local value proposition through this idea of a social license to operate. And it dictates and provides the underlying principle around all of the decisions we make in terms of our activities in the community and how we deploy research infrastructure is informed by this idea, and how we're developing and building our social license to operate. And this doesn't just come naturally, it requires directed interventions. And there are a couple of, as a summary takeaway slide, there are a couple of areas in which we currently do deliver and undertake various interventions. I think I'll stop there. I'm not sure if there's time for any questions, or which I'll be happy to take now.
Okay, thank you very much, Adrian, for this presentation. Let's give the speaker a hand. And I propose we discuss the questions then during the round panel afterwards, so if you can stay with us. And our next speaker will be Gian Kamel, originally from Cairo in Egypt, studied in Sapienza in Rome, and is now beamline physicist at the Sesame Light Source. Yeah, and she will tell us about this beautiful project that is contributing to peace in the region. Thank you. Please.
So, warm welcome to all of you here and also those who are watching us online. It's my sincere pleasure to join you today in ICRI, and I thank all the organizers for this opportunity to highlight my facility. I would like also to invite you for the next 15 minutes to join me in this, let's say, short tour to Sesame. Sesame is actually a particle accelerator. It's a synchrotron light source, and it's the only facility of its kind in the Middle East. It stands for synchrotron light for experimental science and applications in the Middle East. I would just point out the fact that you will know that later on, if you don't know about Sesame so far, why everything is theoretically impossible until it's done. And I would like also to pick your attention to the fact that perspectives matter. So it could be a land for you, is a boat for us. And don't ever forget that the Middle East is a planet by itself. It's not a piece of our Earth, it's just another planet. So I came from Jordan 2 days ago, and I hope that I can go back, find Jordan in the same place there. This is the region, and it's totally shaped by geography. A lot of cultures, religions, traditions, nationalities, languages, a lot of barriers, and a lot of borders. And I sometimes, with my colleagues, try to joke and go to Wikipedia. You will find something written as the current definition of the Middle East, because sometimes just one country today is belonging to the Middle East, the next day is not. So I tried once also to get to understand my region, and you find also something like this map on Google. So apart from the nationalities and religions and cultures, there is also love and hate that also shapes this region. So you find love, strained, hate, and this map is also interactive. So you can click and try to follow what's green, what's red, and so on. And it's not surprising that you can also find so many books about the missing piece in this region. So everybody is asking what's going wrong with this region, and what we are trying to do at Sesame is to, let's say, to highlight or to prove that we can do something right in this region. Another point that's not also surprising to many of us there is the brain drain issue. Everybody is trying to live, everybody's trying to get better chance, better opportunities, better job, better life. And this is another challenge that we are all facing. There are a lot of stereotypes about women in the Middle East, apart from their nationalities or religions. but a lot of arguments are there. And if you expect someone to tell you that you don't have the right to drive a car, and if you don't have the right to take this scarf out of your hair, I put it because I want to put it, but some people are forced to put it there. How do you expect that these people can advance a career in the science or technology or engineering, for example? I was told once by one of my university professors, I was studying physics, and he told me, you don't belong here, you belong to art or literature, but you don't have the right to study physics. And that was actually the strongest push I took in order to proceed in this direction. I hope that I hope that he can listen to me now and knows that I'm principal scientist in a particle accelerator. Apart from this also, we have a lot of diversities. Those we are trying to overcome, and hopefully we also manage to do that. And the best place to overcome all these barriers together proved to be synchrotron light source, facility that admits only the scientific merit, the expertise, the experience, how good you are in doing your job. Doesn't matter where you are from, what your religion is, what do you wear, and so on. This is the radiation that we are dealing with at Sesame or at any synchrotron facility. We are dealing with synchrotron radiation. And first light was observed in 1947, and actually last April we were celebrating the 75 years of this radiation. It's one of the most influential tools in scientific research, and we use it to explore microscopic world. What we do there, if someone is interested to know, is that we are producing different energies, starting from X-rays, ultraviolet, infrared, and visible light. And we do experiments on basic, fundamental, and applied science for different applications, for physics, chemistry, biology, medicine, agriculture, and all what in between. And sometimes we also have fun, working on cultural heritage, archaeology, human remains, mummies, and many experiments of this kind we also performed and plan to perform in the next future. So synchrotron light facility by itself is a unique facility, but what makes Sesame unique facility for us is this map again. I come back to geography. These are the current members of Sesame. And if I want to name them, they are Egypt, Cyprus, Palestine, Israel, Jordan, Turkey, Iran, and Pakistan. And if you are following news, ABC is that these countries, it's impossible to bring them together. If I tell you my experience as a human being, not just as a scientist, everybody knows about Palestine and Israel, Iran and Israel, but you can find others if you dig into the issue. There's Turkey and Cyprus, there's Egypt and Iran, there's Egypt and Turkey. So bringing all these people together under one roof to do something that's finally useful to their region was really a challenge. And so far, we succeeded. Sesame took around 20 years or more from just being an idea to being in an operational synchrotron light source as we have it today. And this took a lot of international support, backing, a lot of cooperation, solidarity, and it needed a lot of peace in the region to have it finally existing. We have also a lot of observers Those are providing us with scientific expertise, technical expertise, and financial expertise, because I cannot deny that we have a lot of economic problems to run the facility. The main objectives of Sesame are, as any facility, to foster the world-class basic and applied science, development of industry, address regional and also global concerns, to reverse the brain drain issue in the Middle East, and also to act as a bridge for peace and mutual understanding between its diverse societies. But we also noticed that it provides a channel to promote capacity building, to promote gender balance, diversity. And in general, we call that it works in a democratic mode. It's something that we don't have in general in our life, that we use the scientific cooperation to promote peace and understanding between people from different religions, races, and political systems. The lesson was learned based on CERN, actually, that successful bridge building through scientific collaboration is based on something that should be very important, and people mostly think about diplomacy. And we would say that CERN was established after the Second World War. There is no more, hopefully. But for us, we needed to prove that there is nothing called diplomatic science for us, because it doesn't work. You need to prove that you are doing something. You need to provide something to the society. So we had to rely on the science. And again, many of you already spoke about that, we all share the same diseases, same pollution, energy. We have problems with economy, food security, disaster management, and for us, actually, it goes beyond the individual capacity or budget, not only for Sesame, but also for emerging light sources, such as the African light source. We hope that we can lead also and help other emerging sources to follow us. This is, I always show for ending my presentations, that this is the map of the world as seen by politicians. But this is how I think it should be seen by us. We should have borderless map, because we are scientists. And we have to have borderless support and borderless cooperation. Because again, we are all involved. I always get maps because my father was a geography teacher, so I'm fond of maps. The map to the left shows the collaborations, scientific collaborations in just 4 years, from 2008 to 2012. And the one to the right shows, again, these borders. So regardless of any flag, regardless of any label, scientists manage to find a way between each other. This is Sesame. It started by a donation. So this ship that you see to the left was what's supposed to be Sesame 2002, donation from Bessie, from Germany, not Bessie 1. But with an extensive upgrade, it became the picture that you see to the right as Sesame in 2022. This is a picture that shows you science diplomacy in action. So it's hands-on science diplomacy. This is one of Sesame's engineers at CERN testing one of the magnets of our accelerator. And in just one picture, you see collaborations between Turkey, Germany, UK, France, Spain, Pakistan, Cyprus, Italy, Switzerland, and Israel. Nothing better than this picture that proves what science diplomacy means to us. Sesame was opened in 2017, In 2018, it became the first associative LEAPS, the League of European Accelerator-Based Photon Sources. And in 2019, it became the world's first, and only so far, large accelerator complex to be fully powered by renewable energy with a very generous support from the EU. We, the staff of Sesame, try to cope with whatever we have, whether it's environmental or financial or political situations. We do our best. We have developed a community from Sesame members and beyond from all over the world, again, because science is global. We really rely on this community because we don't think that we would ever achieve anything without having a community that believes in us, as we do believe in them. I would just end with something. I have 0 time now, but before ending, I just deliver a message that as long as we have those who like to fight and use weapons and guns and rockets, we also, part of this community, are trying to use science and peace, not to kill, but to live. I thank you so much for myself, on behalf of Sesame staff, and on behalf of our community. Thank you.
So this was really an inspiring presentation. Thank you so much for this one. And I think we will have time afterwards in the discussion to follow up on it. Our next speaker is Sun Oh from Korea, South Korea. And he has been working on the ALICE experiment at CERN, and then he went on to further underground physics in his home country, building up actually a whole network of research infrastructures and transforming the science policy in his country. Thank you. Please, Mr. Sun Oh.
Thank you, Chair. And I'd like to thank the organizers. It is my privilege to be invited to this nice conference to give a talk, and I'd like to thank my speakers prior to me because they have presented FCC and Scale Kilometer Array and Sesame. It was a very nice talks. And I'd like to talk on a like-minded history of how the concept of the research infrastructure has changed in Korea for the last 60 years. In this talk, I will describe how the concept of research infrastructure have evolved. When the Korean War was truced with an armistice agreement in 1953, South Korea was desperate to rebuild its war-torn economy. A recent article noted that the number of the science and technology research manpower was just 1,700, less than 1 person per 20,000 of the Korean population at that time. And the annual R&D fund was about $1.2 million in 1963. That is, on average, about $700 per person, per researchers. So that is a very, very short of the necessary money. Thus, only a few of the researchers could receive some ample or sufficient amounts of the research grant. Before 1960, the idea of R&D was virtually non-existent within the Korean government. Thus, then the Park government took power in 1961 and set up the Economic Development Project, 5-year socio-economic development project. The government regarded the science technology as an essential strategic tool to push the project. The Chinese characters for the science and technology catchphrase here, you can see, means with science, let us build up our country. With technology, let us stand self-reliant. Thus, which is similar to the Kingsman's phrase. Then, Korea's first concept research infrastructure has been realized in 1966 by establishing KIST, Korea Institute of Science and Technology, its first research institution, and together with a law specifically legislated for KIST in the same year. And in 1967, another law for the promotion of science and technology in general was enforced, and a sub-ministerial bureau for science and technology was established within the government, which soon was upgraded to a ministry later. Well, then, after KIST, a large number of national science technology research institutions were established at various levels as the size of the Korean economy began to expand, such as institutions for graduate studies, for policy making, for evaluation of science and technology policies, as well as research themselves. Those national science technology institutions have formed a big cluster to lead research and development on science and technology of Korea, attracting tens of thousands of researchers from abroad, mainly Koreans. And this is a web page managed and operated by the ministry, and you can see that from 1963 to 2020, the size of the R&D budget has increased quite exponentially from 1.2 million US dollars to 93,000 million US dollars in a span of 60 years. Also, the share of the R&D budget on science technology within the government budget has increased by more than 20 times, from a mere 0.23% in 1963 to an almost 5% in 2020. Please remember that the increase is a little bit first slow, but later it is quite rapid. And meanwhile, the number of universities in Korea has also multiplied and produce a huge manpower in science technology. In 2020, about 130,000 students have graduated with S&T degrees. And please note that number of universities increased first quite rapidly, and then it is somewhat slowed down. So please note that the rate of increase of the manpower is different from that of the R&D budget. As you see, the increase of R&D budget could not cope with the increase of human resources for research. This implies that in some period of time, there has been shortage of research money. So many qualified researchers could not have sufficient research facilities in their laboratories. As the scales of the facilities become larger, more sophisticated, more expensive, the situation in some field of research becomes worse. So how to solve this disparity, or how to provide the necessary facility to those who have not? And KBSI, Korea Basic Science Institute, came as a solution in 1988. Korean government established KBSI with the regional centers located in key cities such as Seoul and Busan. The main goals were to purchase on its own the most needed high-end facilities and then to lease them to the researchers who have not. In this sense, KBS played as a provider of the facilities. Well, in this way, the government could save R&D money, the researchers could access the necessary facilities, and a kind of cooperative researchers could emerge among those who utilize the same facilities in KBSI. KBSI also built up a database of who has what about the research facilities across the nation. It has been serviced as an online platform for who needs what, as the database provided information to the researchers where the particular facility is located. So the platform is a kind of online brokerage for research facilities, so just like Uber cab for taxis or Airbnb as tourist hotels. And then Korea has started a kind of fervent fusion or collaborative researches just 2 years after the KBSI was established. At the time, the Korea Funding Agency, National Research Foundation, NRF, has started in 1990 a program for collaborative research among universities. It is called as Engineering Research Center and Science Research Center, encouraging them to make a team for common research facilities. The main principle is that simply do not compete with each other, just collaborate among the universities. I think the similar program is also in the Germany, so Verbundforschung is the word from the German program. So far, more than 300 centers have worked, and 73 centers is in operation in 2022. So let me explain that host university should have more than 6 professors of the same field. It is not the same field. It means not the same physics, but the same high-energy physics or same solid-state physics. It is a very specific field. And the total number of professors from participating universities should be less than 12 participants. So the total number of professors should less than 20 or 18 for a duration of 9 years. And after termination, after 9 years, the host university should provide their own grant to manage and operate the research facilities from onward. So in this way, the professors could participate as a team and could fully access to facilities of the host universities. So this is nice, quite highly evaluated afterwards. Now, the idea of sharing research facilities was so far very successful that KBSI has set up NFAC as a center with it. The concept of NFAC is that to pursue some Korean value. I mean, we have had spare, share, reuse, or barter has been a slogan for environmental campaign in Korea to reduce waste and overuses, and this is something like that, the NFAC. So it is kind of glued together. Also, this is okay. The online platform made by the KBSI, who has what and who needs what, the platform for research facilities was upgraded by NFAC into ZEUS. ZEUS means Zone for Equipment Utilization Service. more than 80,000 high-end equipment facilities are registered for open use, and several hundreds are utilized monthly. So this is a kind of also success. And there's also register and offer information on international large research facilities through WOLF. WOLF means World of Law Large Facilities. WOLF aims for those who seek international collaboration through specific facilities. So, so the research infrastructure that is figured in the Korea. Schematically, I would say that the research infrastructures may be pictured as a linear system shown in the left, in which the government budget goes primarily or directly to research facilities and then to the researchers to use them. Or, like the middle one, both the money and facilities support the researchers. Or, like the right one, the R&D budgets are used to establish research facilities as well as to grant or to scholarships for the students and to support researchers. So the triangular models are more, I'd say, the more advanced form of the research infrastructure than the first, the left one. Well, in the 60s, the Korean government took the concept of our research infrastructure as a linear system, the left one, by establishing KIST, and the R&D money goes directly to the facilities. At that time, researchers, the number of researchers was smaller than the number of research facilities, so it works well. The R&D money goes directly to the facilities. Then in the 80s, the Korean government adopted the concept of research infrastructure as triangular system in which a part of R&D budget goes via KBSI or NFAC to support research themselves. Anyway, the research infrastructure should contribute to the society in a virtuous cycle, like the infrastructure should produce research outcome and which has the socio-economic impacts and which improve the quality of life and development of economy, and then invest again to the research infrastructures. Thus, the socio-economic impacts are important as analyzed and emphasized by STEPI, Research Science Technology Policy Institute, think tank of Korea, and KISTEP, another policy institute of Korea. Such socio-economic impacts are more important for very large research infrastructure because as the size of the infrastructure becomes definitely bigger than the conventional research infrastructures. So the feasibility, the assessment should be clearly analyzed, and the feasibility evaluations are very important, and they are carried out by NFAC and KISTEP. An example of the new large research infrastructure is LAON. It is a rare isotope accelerator complex for online experiment. Indeed, KISTEP has submitted to the government, to the ministry, a thorough report on the feasibility of the LAON project. After some years of delay, LAON is now under construction again. So this is a bird's eye view of the LAON. And this is a heavy-ion collider with 200 MeV at 400 kilowatts. There are some new technologies. So let me summarize. I'll go back. Let me summarize. I have skipped one slide. Yeah, this one. Yeah. KIST, the first research institution in Korea, published a book named the 50 Years of KIST in 2016, emphasized that KIST has initialized the science technology assessment and huge socio-economic impacts on Korea. The book emphasized that the total contribution of science technology R&D initiated by KIST to the national economic growth is about a quarter of the total volume of the Korean economy in 50 years. So the number as estimated by the science technology people, but anyway, it is quite large. With that, let me summarize. In retrospect, the Korean government put priority on establishing research facilities when it has small seed money by establishing the KIST. However, even at that time, please note that the Korean government already recognized that science and technology are essential to accomplish the economic development and the advancement of social welfare, as you see the catchphrase, and to make Korea a competitive country. Thus, it might be said that science technology for country and the country for science and technology. So, in one word, it was a win-win and one of the many successes in Korea. Thank you. Thank you for your attention.
Our final speaker now is Director of European Southern Observatory, Javier Bacons. Will talk to us about the infrastructure that is truly remarkable because it's a European infrastructure, but actually I understand that the key instruments are in elsewhere. Let's see.
Yes, thank you very much. Good afternoon. I'm the only thing that comes between the session and dinner, so I'll try to be quick. Yes, nice time for me to talk about the European Southern Observatory. We're an intergovernmental organization. 2 weeks ago, we became 60 years old. So that's been going on for 6 decades. Like CERN, we were created on the ashes of the Second World War in Europe. Today, we're 16 member states. We have a partnership with Australia and a hosting and partnership agreement with Chile since 59 years. So it's a long journey. What we do is to enable science through developing world-leading astronomical infrastructures on the ground. We have several of those. I'm going to show you to them shortly and then go to the societal side of things. By the way, another important aspect of our mission is not only build these big things and enable science, but also work together with the community to take the best advantage of them. I'm very proud that we managed to approve a new formulation of our values, which captures the assumptions on which this organization will work in the coming decades. And you can see here some interesting ones which are not particularly easy, but they are a must for us, including sustainability. I will talk about this later. Service to the community, of course, excellence and innovation. This is very much at the heart of anything. We cannot reach any of the other values if we don't focus to start with on excellence and innovation. This is the set of our current member states. Our core is European, but as I said before, we already have an ongoing partnership with Australia and 59 years of collaboration with Chile, which is where we actually have our telescopes, as the chair said. They are all sitting in the north of the Atacama Desert, in the northern part of Chile. Our headquarters are in Germany, in Munich. We serve a broad community across the world. We've got more than 22,000 users of our archive, all from almost all over the world. The core of this is, of course, the member states. We have something like 10,000 very active of these 22,000 users of the archive, which request observing time every year, and so on and so forth. And of course, this delivers science breakthroughs. This is what we work for. And this is just a collage. I don't have the time to describe any of this, but be aware that there's 3 Nobel Prizes in this little slide that we help to enable. So we're very proud of these many other breakthroughs that you may have seen in the media, like the first image of a black hole that you can see here, the accelerating universe. Exoplanets, hundreds of them have been discovered thanks to our facilities. We have a rather broad portfolio of telescopes focusing on 2 sites, on 2 main operational sites in the Atacama Desert. One is Paranal. This is the most advanced optical infrared ground-based astronomy in the world. I'm very proud to say this, and I know this is a challenge to maintain it, but it's been like this for more than 20 years now. And you can see all these big telescopes that we call the Very Large Telescope. It's actually a set of these units, plus something that is unique to ESO, which is the interferometer that we run in the infrared. This is a unique facility around the world. We operate this as an integrated system already today. There's really frontline technology in there, not only in the infrastructure, in the telescope itself, but in the interferometer, but also in the instrumentation that we developed together with institutes, R&D institutes in our member states and beyond. And this collaboration, this partnership with these institutes, with the member states, it's critical to have an updated set of cameras, of spectrometers, of all these devices that astronomers use to learn things about the universe. The other big operational facility we have is ALMA, the Atacama Large Millimeter Array. This is in the Andes as well, 5,000 meters altitude. That's where we have these 66 antennas in there. This is actually a partnership between ESO, the National Science Foundation in North America, and the National Institute of Natural Sciences in Japan. There's also, by the way, participation from South Korea in that project, also Canada and many others. There's more than 20 countries involved here. That facility has been up and running for 11 years now, delivering fantastic science on what we call the cold universe, molecules, dust, and all this gas that ends up making stars, and potentially planets, and potentially life. The infrastructure is just technological wonder. Sitting at 5,000 meters altitude, you know, even thinking it's hard, walking it's sometimes not even possible. So, but we still run this fantastic thing up there, delivering forefront science. So those are the 2 big observatories we have up and running today. We're building the biggest telescope in the optical and infrared regime in the world. This is what we call the Extremely Large Telescope, a 40-meter diameter primary mirror giant telescope of the size of a soccer field. Really a big challenge for all of us, strongly supported by our member states. You have a photo here of the works at the site. This is really close to the Paranal Observatory where we have the VLT. We will end up operating these 2 facilities as a single system as well. That's at 3,000 meters altitude. Lots of manufacturing activities in Europe. We're at full throttle on this and poised to bring our community, or to deliver to our community, this fantastic tool later in this decade, so they can stay at the forefront of worldwide astronomy. Let me move now to the social aspects of this. This is what this session is about. We spend quite a lot of effort in communicating, trying to inspire and also contribute to education. And I have to mention here a rather comprehensive program that we have for training of the young generations. We have studentships, we have fellowships, we contract people from all the world. We don't distinguish here from nationalities or anything. One thing I forgot to say, and I always do, you have to apologize. I have to apologize. We have a science archive that is accessible to every single scientist in the world, and we have the tools to deal with those data. So tell to your people in your countries, if they are interested, they just go click on the archive facility of ISO, and they will be able to use all the data that we have been taken for 60 years now. Okay, outreach, we spend a lot of effort in here communicating to society what we do. We have a planetarium in our headquarters in Germany. We have open visits in our observatory sites to the extent that this is possible. We do lots of educational activities, teacher trainings, school trainings. We help the scientists communicate their results. We host press conferences. So this is part of our engagement with the community, which is also, as I said before, an essential ingredient of our mission. I want to talk about sustainability because that's very important. It's one of our values. Let's not forget that sustainability, it's not only saving CO2. That's, of course, a very important part of it. We still need to save the planet, but it also has these other two dimensions besides environmental aspects, which is the social aspects. And we've heard from our colleague in Sarao about the social permission to operate, which is super important when you have this big facilities sitting very often in the middle of nowhere, and the economic sustainability factor as well. So all these three need to be very well balanced to keep going after 60 years, hoping to go for another 60 years. That materializes in some specific actions. I'm just bringing examples here, not the full breadth of activities that we do. For example, in social sustainability, we have just delivered a diversity, equity, and inclusion plan, focusing not only on gender, but also on disability and other aspects. In Chile, we collaborate with UN Women. That's a super important collaboration with us. They guide us how to engage, how to train women that are interested in STEM, didn't have the chance to do it when they were younger. So we're training them so they can go and find jobs in a variety of industrial opportunities that Chile can offer. Another important step that we have taken, we are co-funding with Chile, with our host state, a cooperation program around the extremely large telescope. This is to develop projects that we are interested in, but that Chile is interested in because we train the task force, we train new generations. These people, can they go and familiarize with Industry 4.0 tools, work in the mining industry, work elsewhere. So this is also part of our commitment to develop a capable task force that we will need in the future as well ourselves, although we're only potentially a minor customer. Environmental sustainability, I have mentioned this, this big hub that we're establishing with the most powerful optical observatory in the world. It's already today being powered by green energy. Last July, we inaugurated a 9 megawatt photovoltaic plant in there connected to the power grid. That's very important. It secures a sustainable future for this observatory, together with many other actions that we do, like geothermal heating, trying to avoid air freight, electric cars, etc. Big punch on our CO2 production is this photovoltaic plant. That's where we consume most of the energy, and that's where we generate most of it. So that has been drastically reduced since last July. Very, very important. There's one more step we want to do, the operation of this big hub of optical astronomy that we will keep moving on during the next decade. We are redefining the operational model. Remember, these things are in the middle of nowhere, in the middle of the desert. We have a power grid, that's all we have. We don't have water, we don't have anything. So we're trying to develop a new concept of operations that it's lean, remote, still high performance. So we're using this Industry 4.0 tools, digitization, so we can run the biggest part of the observatory from people sitting in an office elsewhere, like in Santiago or even in Germany. And that's that's where we see the evolution of this moving to. And again, this is a very delicate sustainability exercise. We have to take into account the three components there: the environmental, the social, and the financial as well. So that's it. 60 years, very challenging, very rewarding. We look forward to another 60 at least. Thank you very much.
Okay, thank you very much for this one. So maybe all the speakers could join me here now on the stage for the audience questions and a discussion on the transformative aspects of the research infrastructures. I'm not sure if Adrian is still with us. Maybe the technicians can check and bring him online. Ah, yes, here it is. So, there were quite some different research infrastructures shown. I'm happy that we have diversity really here, I have to say. That's another good example. Maybe I would, before I go for some questions for the individual people, I wonder, with all this diversity that we have in terms of transformation capacities to science globally, regionally, locally, maybe each of you can let us know, do you think we have some similarity here? Is there something that we have all in common? Adrian, maybe you share your thoughts?
I certainly think so. I think there's a growing need globally that is demanding a socially responsible behavior from any kind of investment, particularly public investments. And I think it's very context driven. And I like to think that the idea of the social license to operate is a key principle that can be implemented absolutely anywhere, and is informed in terms of its delivery and actualization and implementation by the context in which it exists. And I think that's really important, and I think it will be really important going forward to ensure sustainable research infrastructures. And as was mentioned, sustainability speaks to both environmental, social, and economic. And I think that's really a key thing to recognize.
Thanks, Adrian, for that. So Adrian's opinion is what really bonds us together is here this social license to operate. Sun, what do you think about that?
All of you have mentioned about the benefits to the communities, the SESAM and ESO or FCC. And it is true that when the research infrastructure is hosted by a local government, there are some visible benefits as in educations or living standard or the economy of the local community, and even the educational level is upgraded as many PhDs are gathered around the research facilities. It really happened, I'd say that the Korean government in 1980s chosen Daejeon as a place to locate the many national research institutes in that area, and now in Sejong City, and the quality of Daejeon has been upgraded. Other than other parts of the Korean cities, it is very upgraded. So actually, research infrastructures help and contribute to the local society. Yeah.
Okay, thank you. So we have another good contribution here. So what all the research infrastructures brings us together is actually that we have a mandate, not only a mandate, do you think we have like an order of the society to invest into the training? And I like what you say. This is also my personal thing that I like most about what we are also doing at CERN, that we invest into the future generations. It's sustainability that comes by itself. Gian, what do you think? What is our common transformative lever that we have?
I wouldn't be far than what you said already. I totally join what you said. So I think that we all have the responsibility as much as we can offer using the provided resources. Of course, challenges are different from facility to another, but I think we share the same responsibility, the same commitments, and I would say that we should always fight to for a better future, if not for us, then for next generations.
So our weapon is the knowledge, if I understand. Yeah. Javier, what do you think? What's our common mission?
I think I would put together, I think you said it, or it was said in the session previous to this one, excellence. It's the first value that we need to take into account next to corporate social responsibility and sustainability. I mean, we give this for granted, right? That excellence is our goal, but we need to repeat it because it's not always so clear, especially to the governments and to some of our funding agencies. So that's what we pursue. But of course, we have to generate impacts in society. And that's a part of corporate social responsibility that we should keep in mind all the time.
Yeah. May I add something? Absolutely. Just to echoing what you just said. It's something that we all face when we speak about Sesame, because once we mention the member countries, everybody thinks that Sesame is a political project, and there is nothing is coming out that can benefit the society. So we always have to prove that Sesame is a center of excellence. Sesame is an international research center. And we prove this through our users, through our experiments, through our publications, just to go out of the frame that everybody is putting for us, that we are a political project. So yes, excellence is a very, very important factor.
Excuse me. I think you should add that the Sesame is contributing to the diplomatic or political stability in the Middle East.
Yeah, hopefully it's not guaranteed in this way.
Yeah, I like especially this aspect of that excellence has to be there, but I think we cannot take things for granted. As you mentioned also, when you go home to Jordania, maybe, you do not know how the situation may have changed from one day to the other. Also at CERN, it's many, many years after the Second World War that scientific excellence had to be built up. But we can never sleep. We do not know actually what's going to happen. And people may go off and walk off and go into industry, or may not be interested anymore in research infrastructures. Impact is important, I think, not to sleep. We continuously have to work to keep it and to enlarge it. Maybe a question here to Adrian. You mentioned, for instance, you have local training programs with apprentices. Did you get any feedback from them? Do they appreciate these programs, and do you monitor that? Is there a continuous engagement going on, and do people come back, and how does that work a bit?
So absolutely, and in fact, in terms of our workforce that are located in the region, I'd say approximately 90% of that workforce is from the local community, and the Northern Cape province is also, we're not just developing skills and developing people for the research infrastructures, although it's one of the outcomes. The Northern Cape province of South Africa and the Karoo region where we're located is also the site of substantial renewable energy investments. And so we try to ensure that there's strategic alignment in terms of what is ultimately going to be required for those kinds of development, so that we're developing skilled technicians, we're developing skilled artisans that do not then go off to other locations in the country, but actually stay within the region and develop their communities. So there's a real positive impact. It takes a while. We've been operating within the community for close on 15 years now, and we've seen really, significant improvement, significant upliftment, and significant development of local businesses and the local economy. We still have the existing challenges, right? And so the way in which we engage with the community is also very careful, and understanding their needs, I think, is really important. But we do try to track as much as possible, and I think there has been a real positive impact within the community.
Yeah, so that's cool. So Adrian tells us really that they're monitoring this engagement, and apparently there is a positive feedback. So that is really the impact that is generated with the people together. Javier, you told us that you have built this fantastic photovoltaic plant providing the renewable energies in Chile. I happen to know Chile actually because I have family also there, so I've driven by actually these very remote places. On the other side, Chile is also a country in which we see quite a split of rich versus, let's say, not so rich or poor people, and a lot is in private hands. There is few families who basically dominate the economy. Now, if you come and you demonstrate this photovoltaic plant, do you think, or maybe you have even succeeded, do you think a change, a transformation can be induced also at government level? Do they work with you? Do they adopt some ideas and make some change?
Yes, absolutely, yes. I fully agree with what you said. I mean, compared to standards in Europe, Chile is a very unequal country. I mean, all the inequality indices are much steeper than in Europe. Still, it's among the less unequal countries in South America, and moving in the right direction, by the way. Yes, I mean, this photovoltaic plant has been fully built by Chilean companies, and we actually don't even own it. I mean, they have built it, they operate it, and they provide the service, they will maintain it. So all the know-how is there. And for me, this is a very important asset that also benefits us. The current government is very supportive of an ecological transition, and that's also another advantage. So yes, I have all the hopes that this will influence other parts of the country as well. Absolutely, yes.
That's super. Just, I don't know if I'm allowed to ask, but I ask it anyway. Who paid it? Was it ISO who paid the photovoltaic plant, or did the government or cooperate?
No. No, we didn't pay for it. Ah. But of course we're paying the energy provision. Yes. Okay. It's a bit different as it works in Europe. Power prices are regulated by the government in Chile.
Okay, thank you very much. So we see that the research infrastructure can make actually a dent locally with the population. We see that even some sustainability actions go up and have the potential to influence governments. That's a great thing. Gian, you have told us there are, what, eight member states now of Sesame. What's your opinion? Do you believe this is going to grow? Is there a transformation in the region going to happen also?
Well, I would just say that we are still a young facility. So if you think about the fact that people started thinking about having such facility in the late 80s, and then it started to move slowly in the beginning of the 90s. And Sesame was opened 2017. It took years and years. So I would say that we are all surrounded by the situation in the region. So it's not only the economical problems, but also the political problems, and this slows down a lot. So I would say also during the, for example, something that I lived myself, if there is a problem, a political problem, and a special Sesame member, it affects a lot. Because these members pay the contributions, annual contributions, and this is dramatically affect the budget. And if there is no budget, then there is no machine, there is no science, there is no community. So nobody can guarantee how long Sesame will be live and how long it will continue. We only hope that we keep moving forward, even if we move slow. It's the best thing that we can do. step and step and step. It doesn't matter to be like, I don't want to say something like one of the best synchrotrons all over the world, but let's say just having it going forward better than nothing at all.
I think that's a really good message. Actually, the sustainability comes from the small steps, isn't it like that? It was always like that. You build cathedrals not from one year to the other, but it goes over decades and potentially even centuries, and each one just puts a block on it, and that's how a thing grows, and it's affordable, but we have to keep the interest up. So, and that goes with the scientific excellence. And here I like, Sun, what you said about your platform, where people now can go in and they can reach out and they can say, I need some science infrastructure. Where is it? Can I go to it? Now, my provocative question is that's a super idea, this broker platform. But is really everybody in Korea playing with you? Or do you experience there are some organizations which rather, you know, do their own kitchen?
No, it is quite open, and it is not centralized, but it is quite open to all. So not such activities. Yeah. Okay. So it is open to all, and they can use any facility if they want. If the owner allows, yeah, then the visitor can use the facility with a small charge of the usage. Yeah.
So the idea is here actually not to enforce that the research infrastructures come together and do something together with a regulation or a law or anything like that. But what you rather do is you propose something, you create a platform, you invite, and who wants to join comes in and see actually if it gives an added value or not, or how far it gives an added value. So I take here also a question from the audience that I received, and I'm just going to read it out. If with my glasses I succeed, so your apologies, it's very small. The local governance is certainly supporting and welcoming your project and implantation, but were they an asking party, or did they become a partner once you had made your kind about setting up Meerkat? So that goes to Adrian, at that location. How much of a community strategic choice influences the choice of location?
So the nature of constructing an astronomical facility is that the first thing you need to do is really look at the scientific qualities of the site. Right? And the nature of the site for the Meerkat is that it is naturally within a very remote location. So after really doing a key scientific analysis, we then have to engage with local stakeholders. And in fact, there's a substantial consultation process. And we do what in South Africa is called a strategic environmental assessment. So it not only looks at the environmental impact, but also the potential social and economic impact of establishing research infrastructure in the area. And it requires us to undertake various mitigation actions that may potentially address certain risks. So there certainly is an upfront engagement with local government and provincial government, and there are various formal structures that were put into place, but also as an ongoing process, and certainly before there's any kind of approval of constructing something like the Meerkat or any kind of infrastructure within the area. There's a long consultative process that takes place, engaging both with local government as well as local communities and landowners within the area. And only once that process is completed, it's a multi-year process, is there any kind of approvals of construction and contracts within the area. So I think that's absolutely very important. Particularly when we're talking about astronomical facilities, because the preservation of the scientific quality of the site is also dependent on the buy-in and support of the local community, and they need to see the value of that project as much as the researchers and the users that are going to be utilizing the facility.
Okay, thank you very much for the clarification. I hope that the one who asked the question got the answer. Do we maybe also have a question here from the audience? Anybody? I see that people are looking forward to Czech beer. We're here for knowledge, right? So anyway, we don't want to be in between the people in the dinner. Maybe a last word from everybody. We make a round soon.
Actually, I have learned a lot from the SKA, ESO, and SOSAMI, as well as the FCC, which is I'm familiar with. And I think all of the large research infrastructure has certain kind of socio-economic impacts as well as some social benefits. So I think this kind of research infrastructure should be encouraged in a positive way. Yeah, that is my opinion. Thank you.
Thank you. Jian?
Yeah, actually, from my experience, I would say that trust is the most important factor when we deal with each other. Life proved that. And I'd like to see you in Jordan. Actually, the first place that I visited when I went to Jordan before Sesame was the Dead Sea. And Dead Sea is famous being the lowest point on Earth. I always have something to say that from the lowest point on Earth, the only way is up. And this is something that's translating why Sesame actually. I think it's my belief that Sesame is located in Jordan to take us up. Thank you.
Fantastic. Yes, I've been there actually. That is also the lowest bar in the world, actually, if somebody's interested.
It's always lowest.
Javier, last words for today.
Not much to add to what my colleague said. One topic we haven't touched, and I'm not going to open it now, it's the importance of governance of our organizations. This is so critical to make sure that we have our member states, our stakeholders behind our projects. That's so important. I've seen it working very well, thankfully, in our case. I think it's just perfect. Sorry. I have seen it not working not so well in other cases, and that's so critical. Yeah. So.
Yeah. No, don't worry. I'm used to that.
I'm absolutely amazed about your infrastructure. I mean, that's all. Thanks.
Fantastic. Adrian from South Africa, the last
Sure,
words for tonight.
Thanks for the last words of the evening before dinner. And I think delivering socioeconomic impact and delivering broader impact, I think, should be seen as a critical success factor for the delivery of excellence in science from research infrastructures. It is not just an addition; it is part of that excellence. And I think we, many of us kind of take some time to think about, well, what is our value proposition, not only to the scientific community, but to our stakeholders, our key stakeholders within government, within local government, but also the community, because they are all part of the project, essentially. And I think once we have that resolved, I think future sustainability and success of research infrastructures is extremely promising.
Yeah, thank you so much for that one. If I may add to that one, I see that we do a lot to engage all kind of people outside the research infrastructures. But my wish would be that also within actually the science, we stay close together. I think there's a lot of diversity, and diversity does not mean that necessarily there has to be a conflict or competition. I think there is room for everything. Of course, there has to be consensus building. The scientific excellence has to be there. But I think we should not try to be scared now. Are we evaluated just by socioeconomic impact figures, or do we meet the UN sustainability goals? I think actually we all in our research infrastructures have tremendous potentials to implement these goals and to work together towards them. Maybe we need a little bit of training to document that and to show it, but I think we should not now be afraid to be measured by that, because I think we do all excellent science. And I think it was a great discussion. Thank you very much. And continue it over dinner time, because that's why we're here. And enjoy the beer. Thank you. Thank you.
Thank you.